are the risks associated with the change and the inevitable change that's going to be taking place in relation to artificial intelligence. And then the third question is focusing on the authoritative voice of Met Services, who provide essential early warning systems to support life and property. And it's really focusing on those questions and having our speakers address those. Of course, any other question can be posed by you, the Executive Council, during the session. Okay, so in the interest of time, you don't want to be listening to me. I'm going to start off with the short presentations. They're going to be lasting around 7 minutes each. It's a very short period of time, but the idea is for the presenters to perhaps highlight their perspectives and their ideas and to share their thoughts in relation to these questions. We'll take all the presentations together, if that's okay. We won't stop after each little presentation and open the floor for questions, or we'll never get through it. So we'll take all the presentations together, and then there'll be hopefully around 40 minutes to be able to take questions from the floor. Is that okay? Right then. So I'll actually start by giving the floor to Michel Jean, who's you might remember, the president of INFCOM, to start his presentation. Over to you, Michel.
So thank you very much, Chair. So good day, colleagues. First, a few general comments, and then I will provide a perspective on the questions that have just been introduced by the Chair here. Next slide, please. So where we are today, thanks to the World's Weather Watch, we are where we are because of the successful program that got established back in 1963. It's all about the establishment of a global framework for observation, data exchange, and data processing. So the rapid and transformative development of AI is truly astonishing. As president of the Commission, I do keep with the technical literature. It's absolutely incredible the speed at which the progress are being made. Yet on top of that, the convergence of a new generation of AI systems linked to the availability of the next generation reanalysis. For example, ECMWF is working on ERA6, and there are other national efforts, will likely drive improved accuracy of AI-based predictions. This being said, the emergence of AI does not render past and current effort obsolete. The value of observation and physics-based forecasting remains unchanged and will remain unchanged for the foreseeable future. For example, the reanalysis are key to the successful development and implementation of AI-based prediction system. One quick comment is the fact that when you look at the diagram on the screen, it's all about the value cycle associated with weather and climate services. We're focusing a lot on AI technology in the context of numerical weather prediction, but there are AI applications all across the value cycle, from observation to data exchange, and of course on the post-processing of the information. In light of the roles played by NMHSs and the WMO's global infrastructure, it is essential that we continue to deepen our mutual understanding and strengthen our collaboration with the private sector and academia. To get the best out of all this, we need to combine expertise in data science, observing systems, Earth system science. Of course, we need to work together. We're all in this together, actually. Now, allow me a quick overview of some key points associated with the questions suggested by the Chair. And as usual, Mr. Chair, I will not go through an answer to each of your questions, but rather extract considerations for the group here. So next slide, please. So first of all, there's the whole issue around openness, transparency, traceability, and interpretability of the systems. So this is foundational to the World Weather Watch and the expanded World Weather Watch that we're working on. Why? To prevent misleading information, to enable the effective and trustworthy use of systems and product, and to achieve explainable and interpretable AI-driven Earth systems prediction. Those 3 points require a clear understanding of the methodology, the underlying data, and performance characteristics of those systems. This also includes an understanding of how the training data sets affects the AI ESP model forecast capabilities and the sensitivity of those systems to the training data sets, because my expectation is that there will be multiple training strategies before we get to a point where we have some form of a standardized framework to actually develop that. So next slide, please. Second point is about the public-private sector to engage and work together in a shared and open platform. A few key points there. There has to be commitments to practical standards and regulations. Otherwise, it will become extremely difficult, coming back to my point on interpretability that I raised earlier. There has to be commitments to transparency and sustainability. And the commitment must include long-term sustainability of the engagement. I mean, developing a fire truck is one thing, but I mean, if there's no sustainability of that fire truck when you need it, then of course, that's a problem for countries who are actually using those systems in mission-critical decision-making. There has to be an alignment of the various policies between all the players. And the alignment and commitments required are not one way. It's not for the private sector to adapt. It's for both parties, actually, to adapt each other for this brand new world, dealing with the private sector and academia as, provider of infrastructure to the organization. Next slide, please. Ensuring that those systems are trained on open, high quality, and data accessibility. So we have a number of pillars that are key to support this. I mean, the WMO, a unified policy for the exchange of data, being enabled by the WMO information system. I will raise the WIGUS metadata, which is essential to ensure long-term known quality of observation and the long-term intercomparability. And to me, this is fundamental, actually, for the high-quality training of AI ESP systems. Last but not least is the consideration for commercial arrangements with engaging with commercial providers. We must carefully consider the ownership of data, metadata, licensing, and things like that. And some work is actually being initiated as part of the Infrastructure Commission to explore this in collaboration with the Research Board, actually. Next slide, please. The transformative potential of AI I mean, there's an extraordinary potential there in addressing capacity challenges faced by developing countries, least developed countries, and small island developing states. My goal really here is to accelerate the bridging of the digital divide and allowing access to service based on the latest science and technology worldwide, through the establishment of global and regional platforms that would allow, national systems to actually connect and be linked through all that, globally based system. It will provide enhanced predictive capability, and that will help us achieve and accelerate our objective related to the UN Early Warning for All initiative. Reducing the computational burden for the users, filling observational gaps, supporting downstream applications, and the knowledge transfer and training. The potential is fantastic. Next slide, please. Last but not least, there are 3 points here. And the purpose of the discussion is really about, some policy and governance aspect. Allowing non-traditional sources to the WIPs. Non-traditional sources considered as private sector entities, academic sector, or non-partner international and intergovernmental organizations are envisioned to contribute to WIPs, especially through AI-based solutions to support, all the applications that we drive. The components of the how are explored this morning and later on this week. And of course, that dialogue will continue over the coming months. My hope is that through prototyping with our partners, with the private sector, with academia, is that it will actually help us frame the kind of methodological framework that we need to have to work collectively for the benefit of all. Along that line of thinking, do we need a CGMS-like mechanism for AI? So CGMS is the coordinating group for meteorological satellites. So we have something in place for decades now that works pretty well. Maybe this is what we need for AI. So I do hope that out of this discussion, we will get some guidance on that. Finally, through better support for decision-making, AI can potentially automate forecasts and warnings and generate optimal user-focused impact-related indices, which directly support NMHSs in providing critical information for disaster risk reduction. However, the reliability and ethical implications for decision-making need careful consideration. So there's a full ethical aspect of this that needs to be taken into consideration. Next slide, please. And I will conclude on this. With the agreement of our colleague and friend Charlie Ewan from the UK Met Office, he sent a very interesting LinkedIn post over the weekend. And I have extracted 3 of its points with respect to AI in the context of the adoption of AI in companies, enterprise, organization. I will let you read this. You can read as much as I can as well. But there are 2 fundamental points there. The third one, which is about smart companies are recognizing that the strategic need is actually about being able to move faster, innovate, and adopt technologies more effectively. So AI should be the trigger, not the catalyst. It should be the trigger and catalyst, but not the thing, because everybody talks about it. And the 6th one, the key challenge to most organizations are not ideas, platform, or prototypes. We're all smart. We are all smarter than our neighbors. We all have good ideas. But the key point there is you need to adopt it at some point in time, and you need to have the proper mechanism to actually do that properly. So with this, Mr. Chair, I'll stop there.
Thank you very much, Michelle. You've covered a huge amount, highlighting, of course, that AI shouldn't necessarily be the primary focus. That's our mission and the outcomes that we're trying to achieve. You've highlighted the ethical aspects, that we need to take a partnership approach. We're all in this together. So far, the WMO has created a magnificent common good to protect life and property. You've highlighted the importance of policy, governance, or opportunity to accelerate addressing the digital divide and the need for all of us together, public, private entities, academics. We all need to co-adapt and learn from each other to address this issue, focus on issues like you've highlighted. Thank you very much, such as explainability, trustworthiness, and interpretability of the systems on an ongoing basis. And quality, of course, is paramount. So thank you very much for that. Next, I hand over to Dr. Roar Scallon, who's the Director General of the Norwegian Meteorological Service and a member of the Executive Council. Over to you, Roar.
Thank you very much, Owen, and thanks for the invitation to take part in this session. My starting point for this presentation is the goal of ensuring that all WMO members can benefit from the use of artificial intelligence in Earth system predictions. And the presentation will build on the experience we have from European collaborations on AI over the past 18 months. And as you can see, it's co-authored by colleagues from Met Norway and from ECMWF. Next slide, please. So for decades, our community has adapted to and benefited from technological changes. But as Michel Jean just said, what is happening now is not just a technological change, it's a more fundamental change. And for decades, new technologies is one of the reasons why we have seen the constant improvement of skills for weather forecasting, what is often referred to as the quiet revolution of NWP. So while this is not just a technological change, it is in fact reshaping how and by whom forecasts are produced. AI models and tools can generate products directly from data. The forecasts can be targeted for specific purposes, and as we have seen over the past couple of years, the forecast can be produced by students as well as huge technological companies. So, can we trust all the data that comes out of these models? And what should be the roles of our national meteorological and hydrological services in developing and operating AI solutions? To build trust and accountability, and to avoid lock-in in a very fast-changing technological situation, and to enable all the NMHSs to benefit from this change, the systems that we develop and start using should be truly open. That means open models, open weights, open tools, and not at least open training data. So to be able to take a leading role in the development, and to understand the possibilities and limitations of AI, we need to collaborate. In Europe, we have set up together within the European meteorological infrastructure, which comprises both EUMETNET, ECMWF, and EUMETSAT, as well as all the NMHSs. We have pulled our resources together for open AI developments. We set up a program under EUMETNET called EIA. It's shared by the German Weather Service. Currently, some 400 developers and scientists are involved, and they develop open tools covering the entire value chain from observations to services. The EIA program, as well as ECMWF, provide training sessions which are recorded and can be used by all of you. And within this collaboration, we also set up a framework for testing and comparing models and tools, realizing that there is no fixed solution yet. This is a highly developing field. We don't know if we are doing the right thing, but we need to test and verify what we are doing constantly. So I will now illustrate some of the tools and results that we have achieved within these programs, focusing here today on weather forecasting and the particular results we have achieved together with ECMWF. So next slide, please. You probably know that ECMWF has developed the Artificial Intelligence Forecasting System, AIFS. The AIFS single versions of the deterministic model was implemented as an operational model in February, and the ensemble version is planned for this summer. The AIFS shows skill comparable to or exceeding both the physical IFS model and private sector systems. This shows that AI is not just under development in the public sector, but it has already transformed operations. And we have developed together with ECMWF the Anemoy, which is an open source ML software framework for Earth system modeling that can be used by any of you now. Any of you can take part in the development. Very many European NMHSs are now partners in continued development of Anemoy. ECMWF has developed Forecast in a Box, which is comprising AI models and the entire workflow from input data to visualization, with the goal of enabling NMHSs to easily set up an AI-based prediction system. And I should also say here that the Anemoy won the 2025 European Meteorological Society Technology Achievement Award. All of this with the goal to make open source AI easily available to NMHSs. Next one, please. In Norway, we have developed Breeze, which is a global open source AI-based model using a stretched grid, so we can have a very high resolution over our focus areas, as you can see on the figure there. It's based on Anemoy, of course, and it's based on the AIFS global model. And with this model, we can seamlessly cover nowcasting, so the next hour up to sub-seasonal 21 days. So eventually it does the same as for physical models currently. And we are now testing to move the focus area with high resolution to other countries and regions, both in Europe and outside Europe. And as you can see, one of the areas that we are using it for is Arctic, which is a very data sparse area. So how can we take all of this together and bring it to the developing countries? Next one, please. We have started a pilot project with Malawi, aiming to empower Malawi's National Meteorological Service to independently operate an AI-based weather prediction system. The wider goal is, of course, to test how AI can be used in the value chain of producing early warnings in all developing countries, and least developed countries and small island developing states. So this is a pilot for now. It's a partnership between Malawi's Department of Climate Change and Meteorological Services, which brings local services and local data to the project. Met Norway, we bring in Breeze, domain and AI expertise, and ECMWF brings in the forecast in a box. We believe this will be a sustainable system because Breeze is maintained and used by us, and forecast in a box is maintained by ECMWF. The WIPS, we will have a separate WIPS pilot project on this, forecast in a box and Breeze. That is briefly mentioned in the document we will discuss tomorrow morning. Thank you very much, Owen.
Thank you very much. You've covered a huge amount, demonstrating how the technological barriers are breaking down now and allowing countries to leapfrog potentially to a state-of-the-art state where they'll be able to provide amazing capability to drive the early warning services to protect life and property. You also emphasized sustainability, and that it's not just about NWP emulation. It's how AI could affect the full value chain, right from data simulation right out to visualization, amongst other things. Roar. Thank you very much for that. Next, I hand over to Arlene Lang, who's the Coordinating Director for the Caribbean Meteorological Organization and a member of the Executive Council and permanent representative of the BCT with the WMO. Over to you, Arlene.
Thank you very much, and good morning, everyone. I'm very pleased to be here to speak really on behalf of small island developing states and least developed countries. And I'm showing on the left here some pictures of some of the things that we deal with on that kind of scale. Next slide, please. So focusing here on the fact that when you look at this picture, this is a picture showing the relative station density. And you can see, of course, where the areas of the tropics and also the southern hemisphere are quite blue. And so in these data sparse regions, we're really depending here on satellite remote sensing and reanalysis to be training the artificial intelligence models. And the reanalysis is rather large scale. And so we're looking at figuring out what is optimal for small island scale in this new world that we're living in. And this was one of the impetus for us organizing the first ever regional association for webinar last July. Next slide, please. And this was a webinar. It's a part of a series of Science in Service to Society that we have in RA4. And this brought together a number of experts, including our very own Dr. Veronique Boucher, who was leading then at the time the task team on artificial intelligence within the WMO Research Board, and Dr. Paul Rober, who has many years of experience with machine learning in the US and looking at short, rapidly evolving weather situations. And Dr. Mark Di Maria, who is an expert in tropical cyclone forecasting, and Dr. Fernando Peck, who is actually presented on the applications of AI in looking at remote sensing and natural hazard management. We had more than 250 participants during this webinar. A lot more were registered, but these were who participated. And it was from all over the world, actually. Next slide, please. So the takeaways from that first webinar were, of course, that in general, some of what has been said already, that these models are performing better or as well as traditional NWP at a fraction of the computational cost. And that, of course, opens up the possibility to democratize access to weather forecast models, where, as was explained by my colleagues, there's open source data provided by private sector as well as packages developed by ECMWF that allows installation and running of these systems. Specifically to tropical cyclone forecasting, which is a big problem for many basins around the world, is that there is a long tradition of simple machine learning models being used to successfully forecast tropical cyclones. So that aspect is not new. What has been found, though, is that there's great promise with regard to tropical cyclone tracks, that there is comparable or better track forecasts than the best operational models. There are, however, challenges with regard to accurate intensity forecasts, which may require different kinds of training or figuring out how best to merge the physics with the data processing mechanisms with the AI models. And with regard to the physics, there's that question about how well are these models capturing any of the underlying physics. We know that it's a lot of matching of patterns. And a very important question is, can these models really simulate that predictability limit, or do they assume that there's endless predictability because they're not really based on the physics? So we need to consider those things. With regard to satellite imagery and natural hazard management, this has been one of those areas that has taken, like a duck to water, where it's ideal for monitoring and mapping floods in terms of merging the data and processing it and getting very valuable information at the end in terms of classifying what the surface looks like, what the flood mapping looks like. Next slide, please. So with regard to the questions that were asked, so the open principle, Michelle already answered a number of these questions. So for me, this is meteorology in its uniqueness in the global interdependence that we all have. The atmosphere knows no boundary, and this openness benefits everyone. And we have a long tradition of collaboration. And for example, there's technology that has transitioned from the university system, the academia and its research to become a private sector service or product, and as well as the experience that access to open data unleashes innovations in the private sector as well. And the question with regard to how can we ensure that these systems are trained on open, high quality data. Michelle already explained a lot about the WMO system of open data sharing, our policy, and the mechanisms within the infrastructure for the WMO Integrated Global Observing System, the WMO Information System, as well as the modeling, the prediction system that we have. These are the mechanisms that are established within our organization and across our membership. A very important question is, how do we evaluate forecast skill? We need to do it in a way that matters in all forecast assessments. We have a lot of people claiming, oh, our model does better than, whatever. How do we really define that? And this is where we need the expertise of WMO and our co-sponsored research bodies like WGNI to ensure appropriate evaluation of AI prediction. Because we have a lot of people saying, they've looked at 2 storms. We have done better. And we need to have operationally meaningful metrics, because that's what the National Meteorological and Hydrological Services will depend on. We need to be evaluating these forecast models in a way that makes sense for operational purposes. Next slide, please. So for the smaller met services and hydrological services, as was noted before, one of the big advantages of AI is that lower computational cost and having that accessibility that Norway is now providing to Malawi. The other thing too is, of course, a lot of what has been done so far has been learning on the ERA reanalysis. But we can look at the fact that AI models could also learn to assimilate observations directly, and then reanalysis could be done at the small island scale. And that could be then used to train the prediction models and give us a better product for our uses. And we can also then look at examples for capacity development that is existing already. So we are looking at WMO and its partners like ECMWF to train and to build that capacity. And this has already been done. We have a recent example of this that was done last year in the Caribbean with capacity development for the wharf on a stick, essentially to improve operational readiness for these kinds of small scales and for met services that do not have a lot of technical capability. Next slide, please. We also are recognizing the need to have this authoritative voice for the met services. And one of the reasons for this is, of course, our national meteorological services have a national mission for safety and for the public good of their nations. And they also answer to the governments. Can we expect that the products of private companies could be trusted in the same way as the main source and the main method by which we get our forecasts? And there is also the matter of outliers within our training data. And do we have the mechanism whereby an extreme event, as for example, we're dealing with warming oceans, and you can get very dramatically intensifying thunderstorm systems or hurricanes. This is where the National Meteorological and Hydrological Services can demonstrate their greater value in these high impact events, dealing with things that are outside of the limited data sources used to train the AI. And the picture on the right there is from the island of Barbados, which is 21 by 15, I believe, miles. Next slide, please. And continuing in that same question, the role that I envision for these entities, private sector, of course, can be much more agile. They're better resourced than we are as National Meteorological Services, but they do rely on a body of data that has been stewarded by the public sector over many decades. So optimally, what we should have is a partnership in development and deployment of these systems. And we do have the examples here of where we can apply what has been done already with AI to extreme weather warnings and services provided for the protection of life and property. Within the tropics, tropical cyclone track forecasting, as was mentioned before, has been shown to be doing very well in terms of providing guidance for early warnings. And we also recognize that there is an opportunity here to look at something like the WMO's catalog of hazardous events and use AI to mine that data so that you can improve your forecast guidance and understanding of specific hazardous risks. And as I mentioned before, there was the remote sensing and the AI, which also supports early warning systems. And I thank you for your time and attention.
Thank you very much, Arlene. And as we face unprecedented impacts and unprecedented extremes within the overall Earth system, your points are very relevant, addressing the nature of future weather and capturing extremes. As you say, partnership is at the center of everything, and driving and maintaining the authoritative voice to protect life and property. You've touched on what Roar touched on, of course, is this amazing developments in data-driven prediction and perhaps use of reanalysis at a smaller scale, but this wonderful development of lower computational costs really giving access to everyone to amazing predictive capability. An excellent point in relation to providing and developing operationally meaningful metrics to guide Met Services on the use of AI in the future. And you've raised questions in relation to how will the underlying physics manifest itself in an understandable way within these predictive systems. And there's a lot more as well. Thank you very much. So we're now going to hear from the speakers representing the private sector, who will share their perspectives. And first, I'd like to hand over to Olivia Graham, who's the product manager in weather, climate, and geospatial AI with Google Research Africa. Over to you, Olivia.
Thank you, Owen, and thank you all. It is truly a privilege to be here with such a phenomenal group of panelists. It's honestly so exciting to see how quickly the field is developing and how rapidly this group has been able to accelerate the adoption of these new tools, because as you've already heard, it is going to take all of us. So thank you for having me. I'm looking forward to sharing with you all how Google is applying AI to meteorology and hydrology and leveraging AI to create new tools to empower forecasters and NMHSs. Next slide, please. These past few years, we've all been witness to the rapid development and deployment of AI. And at Google Research and Google DeepMind, we seek to leverage AI to solve problems of great importance to the world. And weather and climate is at the center of that. We have efforts across foundational research, climate, quantum AI, and AI for science and society. And we seek to do this work collaboratively with governments, IGOs, and communities to ensure that this work is not done in isolation. And we publish much of this work so that it can benefit the external ecosystem and drive the science forwards. Next slide. What we have also seen over the past few years is that AI is unlocking new opportunities and creating new tools, as you've heard from my fellow panelists. AI is driving breakthroughs in meteorology and hydrology. And I must note that this is only possible because of the work done by the public sector over decades to create high-quality data sets that have made this technological revolution possible. As I'm showing on this slide, you can see breakthroughs across medium-range weather forecasting, where now forecasts can be produced on a single computer on the order of minutes with state-of-the-art accuracy. And the promise, as you've heard from my fellow panelists, is that over the next few years, we will continue to see the development of new forecasting tools that are highly accurate and cheaper, faster, and more accessible. This has the potential to become a leapfrog moment, especially for low and middle income countries. Many of the tools that we've produced are already open source, and the models and their weights have been published for use by the external ecosystem, and the methodology has been published so that it can empower other scientific groups. As others have underscored, openness is key for trust, accountability, and for this community to drive progress together. Next slide. I'm going to steal Arlene's beautiful phrase, which is that we must be partners in development. And that is how we seek to show up in this ecosystem. Our efforts are already creating tools which are supporting national hydromet services and the WMO. We are working with the WMO to build AI capacity within agencies around the world so that they can assess the utility of our tools in their operations. As you can see on the left-hand side, we recently conducted a flood forecasting pilot study, which was a collaboration between Google, the WMO, and national hydromet agencies in Uruguay, the Czech Republic, Vietnam, and Nigeria, seeking to understand and quantify the value of country-specific historical data for improving these global AI-based flood forecasts that we produce. We wanted to compare Google's model to existing hydrological models and work hand in hand with these agencies to understand how we might drive forward together. And as you can see from our colleague, this was an excellent experience, both for the Google team, which learned a tremendous amount, and for the Met agencies that we worked with. And actually, just last week, last Thursday, we announced work that we are leading in partnership with the National Hurricane Center in the US, where our new experimental model, which is trained specifically for cyclone forecasting, shows state-of-the-art accuracy on tracks and potentially intensity. But as Arlene underscored, it is so critical that we work with these trusted agencies that can validate the skill of the model in an operational setting. And so I would just like to underscore that we see this as a partnership, as new tools that can empower the hydromet agencies to do the life-saving work that they do, just armed with new tools in their toolbox. We have a track record of working with the NMHSs who have the mandate to issue authoritative extreme weather warnings which protect lives and property. And at Google, we hope to be both bold and responsible, driving scientific progress while working with trusted organizations. Next slide, please. And looking forward to the next few years, I expect to see the following. Firstly, I expect to continue to see rapid progress on technological challenges. We heard from our collaborators at the National Hurricane Center, for example, that they're impressed by how rapidly the science is moving forward. And it's my personal belief that things that perhaps seemed impossible a few years or a few decades ago may become possible through this new technology. I expect that this technological development will create new tools, which, as you've heard, can support NMHSs. We hope that the offerings, given their lower cost and computational resourcing, can support NMHSs in low and middle income countries. And we hope that all will benefit from the magic cycle of research, working collaboratively to ensure that these breakthroughs don't just stay in research labs, but make their way into the hands of forecasters and are used to protect lives and property. Next slide. At Google, this work is core to our mission, which is to organize the world's information and make it universally accessible and useful. And during a crisis, this means giving our users the support that they need by partnering with governments and IGOs during these challenging times. Next slide. We know that people turn to Google in times of crisis, which is why we've invested in crisis response since 2012. We feel a real sense of responsibility to keep our users safe and to provide them with authoritative information. Next slide. And so I'll leave you with a quick overview of our offerings, which truly span the crisis response lifecycle, from preparedness to post-event. And we're investing all the way from technical breakthroughs driven by AI to dissemination tools so that hydromet agencies can reach the people that they serve. There's much more that we could talk about, but I'll leave you with this. We are eager to connect and to partner in support of all of the early warnings for all stages. And we are so proud to partner with the WMO and NMHSs to increase the world's preparedness for and resilience to weather and climate crises. And our hope is that AI can be a powerful tool in support of this goal. Thank you.
Thank you very much, Olivia. And certainly you've touched on the need to connect and to establish partnerships right across the community, focusing on preparedness and post-event response. And of course, Google's mission or focus on the approach to the overall ecosystem is organizing the world's information and making it usable to provide new tools to perhaps make the impossible possible. And being bold, while at the same time supporting the mandate of National Meteorological Services. And you've also touched on, quite rightly, the need to validate the skill of model prediction in an operational setting, and have highlighted the remarkable progress in forecast tracks for cyclone events and developments in the area of intensity. So thank you very much, and a lot more as well. I'm sure we'll touch on those. Thank you very much, Olivia. That's greatly appreciated. So next, we'd like to go back online now, and I hand over to Dr. Kenji Takeda, who's Director of Research Incubations at Microsoft Research. Over to you, Kenji.
Thank you so much. And it's such a privilege and honor to be with you here today. Apologies I can't be there in person, but I hope to meet with you in person soon. So I'm in Microsoft Research. We're a little over 1,000 people worldwide, work on basic and fundamental research, and very much support open access, making our research available to many. And in fact, interestingly, one of the papers that we published called ResNet underpins pretty much all modern AI. So it was a landmark paper that meant that you could train a deep learning network with 150 or more layers. So ChatGPT, all of the AI that we have seen, was actually enabled by this ResNet paper, which happens to be the most cited paper in the 21st century now. But again, it's an example of how the open research that we do in Microsoft Research enables others to build on top of that in many, many different ways. And so we think about research at that sort of level, but there are many other folks in Microsoft interested in weather. It turns out we actually have some weather experts. If you run Windows or look at, say, the Bing search engine, you'll see a weather forecast, and we actually have a dedicated MSN weather team that do work on AI. So that's really good for us in research because we do have some meteorologists in house, but that's purely for those Microsoft efforts. And here we're really looking at how do we partner with the research and innovation ecosystem. Next slide, please. So a little while ago, we asked these fundamental questions in research, and the question we posed ourselves was, what if we could create a single model of the Earth system in the same way that in the old days of machine learning, we would create bespoke models for very specific tasks, and we would have to create hundreds of those models, for instance, for different tasks. Whereas now, particularly with tools like ChatGPT, those models just can do lots and lots of different things because they're trained on lots and lots of different data. And so that's the question we posed ourselves in research. And what if we could create this single model for the Earth system? Next slide, please. And so you may have seen Aurora, which is the world's first foundation model for the Earth system. And you can see the sort of architecture at the bottom there. It was recently published in Nature under full peer review. And it can do many things. And what's quite interesting is this is a single model. So this is not a separate weather model, a separate cyclone tracking model, a separate atmospheric chemistry model, or a separate ocean model. It's that same architecture at the bottom, a single model. And this is really quite interesting because one of the principles of a foundation model is we do what's called pre-training. So in GPT, ChatGPT, the PT is pre-training. So we pre-train on a large amount of data. For Aurora, we trained on over 1 million hours of weather data. Most of the weather AI models at the moment are only trained on ERA 5 data from ECMWF. But we trained on other data like NOAA's GFS data, CMIP atmospheric data, and over 1 million hours of weather and climate simulations. And so the model kind of understands more than weather, or it can tackle more than weather. And so I'll just quickly talk through a few of these things, and then we'll get on to how people are using this. What you can see on the left-hand side is a high-resolution forecast. So all AI weather models can only operate at 0.25 degrees at the moment because they're trained on ERA 5. What we did is we did train on ERA 5, but we can do this what we call a fine-tuning step, where we take a small amount of data to tune it to certain scenarios. And actually what we did then was we used data from 2016 to 2022, which is high resolution data. So that's not enough to train an entire model, but it's enough to fine tune this model. And that's what we did, which is why Aurora is now able to do operational resolution forecasting at 0.1 degrees. And if you go to the ECMWF dashboard that compares all the models, which is a fantastic community tool, you can kind of see, and it's really kind of fascinating how, again, the progress in AI at the sort of architectural level is enabling us to think in new ways. And then on the second from left, you can actually see tropical cyclone performance as well. So unfortunately, in 2023, Typhoon Doksuri affected over 2 million people in the Philippines. What you can see here is Aurora, not tuned for cyclone tracking in any way, being able to predict several days ahead of time. And what you can see here is actually the different tracks. So PGTW on the graph there is the official forecast track, which shows the cyclone tracking slightly north. Whereas the observational data IB track shows landfall in the North Philippines rather than in Taiwan. And the Aurora model actually is able to track that out and actually predicts landfall in 4 days, which was correct. So it's an interesting example of where you can take a model and actually use it without fine-tuning. The atmospheric chemistry is actually from a sandstorm that happened in 2022 in the Middle East. And this is actually using Aurora, again, not particularly trained on any other data, to predict PMT particulates. And it can do that about 100,000 times faster than CAMS. About 1 second of computation time per hour of real lead time. And then what's quite interesting is we then did some training on IFS HRES WAM to see whether we could actually predict ocean waves, which is extremely complex. And we are able to do that by fine-tuning on some of that ocean data. So I hope this gives you a feeling of kind of where we're going forwards with AI, which is not bespoke models for individual tasks, but this concept of a foundation model, which is things like ChatGPT, but here we're looking at it for the Earth system. Next slide, please. And so we just had mentioned, actually, wouldn't it be great if we could go from observations to forecasts directly without having to have a dedicated data assimilation step? Next slide, please. So we actually supported a team at the University of Cambridge and the Alan Turing Institute to develop Aardvark. This is the first end-to-end AI weather forecasting system. This can indeed go from observations straight to forecasts without a data assimilation step. We supported this work at the university as an open research project. And then other folks such as Matt Chandri, ECMWF, you can see here as one of the authors of the paper as well. And we're really excited about Aardvark. We talk about what if we could go from observations to predictions. This is a proof of concept, so it's not quite as robust as Aurora, say, but as a proof of concept, it's tremendously exciting. And so it's an example of, again, the open research that we do at Microsoft and working with the community until we can push the state of the art forward together. Next slide, please. And at Microsoft, our mission is to empower every person and every organization on the planet to achieve more. And we're very privileged to be able to contribute to early warnings for all. Brad Smith, who is Microsoft's Vice Chair and President, is on the advisory group for early warnings for all. The AI for Good team in his group does a lot of work in this area. They actually do work with Planet Labs and the Institute for Health Metrics and Evaluation to do population growth and risk exposure calculations. We provide post-disaster damage assessment to organizations such as UN OCHA. So we do some of that work, but we work with the correct agencies who are responsible nationally and internationally for that type of aid. And then we're identifying populations that do not have access to early warnings, mapping exposure to historical flooding, always working with the organizations, providing the technology and the technological know-how, but partnering with ITU, UNDRR, WMO, and other agencies. Next slide, please. And I'd like to thank the Met Office because several years ago, we entered into a partnership with the UK Met Office, and it's been a fantastic partnership. We've learned a lot from the Met Office, and that a lot of that was centered around their supercomputer capability, which Microsoft has expertise in. Just last week, actually, at ISC 2025, our supercomputer was top number 5 in the world. But we deploy dozens of those supercomputers around the world. They're not a one-off. So we've built up some of that capability. And with AI, we're building up that capability. And again, it's a real honor to be partnering with the Met Office. And as we heard earlier, Charlie Ewan there and Steve Belcher and Penny and the whole team at the Met Office are doing tremendous work in this area. So again, it's an example of how we partner with NMHs so we can learn and we can bring our expertise in a very complementary way, and where the NMHs can innovate to help them innovate. So next slide, please. So again, I just wanted to say, reiterate that, our mission is to empower organizations such as NMHs, and we do that in, to be fair, quite a humble way. because we have a lot to learn. I spent the last 5 or 6 years of my career working on AI in health. And we have taken Microsoft Research Technology, open sourced it, worked with our NHS colleagues who took that model and actually went through regulatory testing, trials, and that's now deployed in Cambridge, where our lab is with National Health Service. And it's used for every cancer patient who unfortunately has diagnosed with prostate and head and neck cancer to make sure they can get treated quicker. And in health, for instance, that's what we do. We empower hospitals, we empower people who develop systems and can create faster treatments for horrible diseases like cancer. That's what we do at Microsoft. We work with the people who are responsible for delivering that to the citizens. And in weather and climate, again, that is exactly how Microsoft and we see ourselves as well. So thank you very much.
Thank you very much, Kenji, for that for presenting the remarkable developments that have taken place in Microsoft and very exciting developments. And you've emphasized the importance of partnership and working in a complementary fashion to learn together and to innovate, to empower everyone, including Met Services, to deliver their essential services to protect life and property. And also, thank you for highlighting and giving us details of the single model of the Earth system, the foundation model for the Earth system, as you've highlighted there. They're exciting and remarkable developments. So thank you very much for your presentation, Kenji. Next, I will turn to the academic sector, and we have Professor Libo Wu, who's president of the Shanghai Academy for AI for Science. So I'll hand over to you, Professor Wu.
The institution firstly. Please go to, it's okay. Go to the next slide. Okay, I'm from Shanghai Academy of AI for Science. This is a newly established institution focusing on the AI for the scientific discovery. So our mission is to empower the innovative scientific discovery paradigm shift and also the industry applications through AI. As you can see that we are mainly focusing on the fields of earth science, life science, and physical science. So our mission is not only just build models. So we are trying to build a kind of AI for science ecosystems. So that means that we are not only focused on the model itself, we are trying to build up from the data platform and also to the wider collaborations with the industries, universities, and other research institutions. So at this moment, we have developed the open data platform and also our model series to serve for the non-AI background research institutions and also students and professors. And we are also build up a very friendly AI computing platform for more people to use our model. Please go to the next slide. Yeah. Okay. So in the fields of climate and meteorological models, we have developed a series model we call it Fuxi. The name is from a traditional Chinese legend. The god is in charge of the weather. We have series models. As you can see, we have the day-ahead model and also the medium and the long-term model. We also developed the Fuxi weather model, which is mainly focused on the extreme weather forecasting. In addition to the weather and the meteorological forecast model, we also developed like the model for air pollution forecasting and also for even longer term, like climate change model. We have developed model scaling the data to even like 100 years to look at long-term climate change. So we have very close collaboration with the meteorological service. Like we have collaboration with the China Meteorological Administration. We co-developed the function model, so which is actually the first atmosphere, ocean, sea ice combined model. And also, we collaborate with universities such as Fudan University to develop the plant intelligence and climate model to help the policymakers to make better prediction and strategic planning for the weather and climate issues. Next slide. Our target is to develop better AI and for better adaptation to risks. So what the meaning of better AI? So our mission is to develop the model as stronger and also multiple functions. For example, in terms of the meteorological services, we can provide predictions and forecasts regarding the temperature change, the humidity, the wind speed, and also we can also develop some other functions towards the industry applications. For example, we can provide the forecast from the pollutant, the sea ice, the extreme precipitations, and also, as we can see, we have collaborated with a lot of industry partners from like the shipping industry, the energy industry, and also the environmental administrations, and also agriculture sectors. How can we do this? First of all, is the rapid computing. I think everybody here are experts in the meteorological services. We all realize that for the meteorological services, the traditional methods always suffer from the sparse data and also very large computing resources demand. But here we also make lots of efforts to save the computing resources by developing end-to-end technologies, and we can realize more rapid computing. And also, we try to combine the data-driven models with the mechanism models, because in order to explain the complex system of the atmosphere, the ocean, the sea ice, we need to tell the experts or the users what's the real mechanism. So that's why we combine the mechanism with our data-driven models. Next slide. So we are trying to develop the open science. I think we think this can really benefit the public meteorological services. How can we do that? First of all, I think we should take more efforts on the local adaptation of AI models. Because like our model, how can we achieve such kind of progress? Because we are highly relying on the EC data, which has long history, very reliable, transparent, and serve for the international, the public purpose. So for the further adaptation to the local circumstances, we have to develop the local knowledge and to combine with the local knowledge and data, and also to revise our model. So in that case, I think we can have closer collaborations with local meteorological service administrations. And for the Global South especially, and I think we can develop all-in-one services for them, because for the Global South, they really lack of the computing resources, like the HPC, the GPU. But we can actually develop such kind of all-in-one services to combine the GPU and other computing, the software with the AI models, and to provide more convenient, more rapid services for the Global South for their meteorological services. Next slide. Okay, here are some cases we collaborate with the China Meteorological Administration practice. We join in the CMA's practice for the AI-driven meteorological model, and we compete with other AI teams to improve our forecasting technologies. So in the past, more than half years, we have achieved very good performance. We also, thanks to the CMA's support, we can use their data to improve our model practice. So that's why I think the collaboration with the ministerial administration should be a better way for such kind of independent research institutions. And we all know that the CMA also developed some policies for the data, open data policies, and also the collaboration with the private sectors. All these policies actually also provide us support for more collaborations with other institutions and also with the governments. Okay, next slide. So look at the future. I think for the science, that kind of independent research institutions, we would like to take more efforts to unlocking the boundless potential of the AI for the sustainable development goals. Actually, we want to take more effective cooperation mechanisms with the meteorological service to tackle the challenges from the climate change, from extreme weather disasters. We can see actually great potential for the AI in such kind of actions. That's it. Thank you.
Excellent. Thank you very much, Professor Wu. And you've put an emphasis on the importance of adaptation for risks and addressing these issue of sparse data and computational resources and supporting the global south and more rapid services to support emergency services. And quite interestingly, you've emphasized the importance of local knowledge and data and adaptation and unlocking the boundless potential for AI. That's an absolutely excellent point. Thank you very much. So all our invited speakers have made their presentations. Thank you very much. So we're going to open for questions, but first I'm going to hand over to the HMEI representative, to Dr. Lydia Howman, who's going to maybe kind of reflect on the presentations as we've heard them this morning and in the context of the questions that we've posed to the various presenters. Over to you.
Thank you. So regarding the first question, model and data, I think, the AI system should be open, transparent, and traceable because that will lead to innovation, collaboration, and development. So I think open data and policies will spur innovation, and that will unlock the opportunity to develop new products. So the HMEI, as you know, is an organization that represents the view of private sectors, private organizations in weather, meteorology, hydrology, climate, and environmental sciences. And AccuWeather is a proud member of the HMEI. So at AccuWeather, we are committed. Our mission is to save lives, protect properties, and help people and businesses to make the best weather-related decisions. And at AccuWeather, we are leading a range of AI-driven technologies to enhance the prediction of complex meteorological parameters like precipitation, lightning, or air quality. For example, one of our recent achievements is the development of high-resolution precipitation using state-of-art AI deep learning techniques. And for lightning, as you know, this is one of the most challenging parameters in atmospheric sciences because of the complex physics and dynamics, and because we don't have observational data as well. So at AccuWeather, we have a global lightning detection network, and we are working towards combining real-time and historical lightning data with advanced AI models to significantly improve the lightning forecast accuracy. So AccuWeather, along with HMEI other members, so we recognize the importance of being transparent and open. And for this reason, we are producing white papers and supporting information to share the insights of our methodologies and services with the public. So we want to be transparent about the nature and scope of our offerings, but we are a private company, and we also need to safeguard our proprietary innovation and business interests. So the materials that we share are designed to strike a balance. So we are providing information, sufficient information to demonstrate the depth of our research and the effectiveness of our solutions, but we also want to protect the intellectual investments. And we do this, we create white papers and supporting information because we believe that the open ecosystem will accelerate research and development, and also will allow researchers to validate results, and motivate cross-border scientific collaboration as well. So we also need to ensure that AI systems are trained with open data sets. So because this is crucial for scientific integrity, equity, and innovation. So sharing data and models is essential across the countries, and there is a strong and growing commitment to make open data accessible as possible worldwide. So I think we can ensure that AI models are built on open data by doing two things. The first one is that open data that we use are clean and reliable. And two, the open data that we have are standardized. So we have AI-friendly formats. For example, NetCDF or SAR, Parquet. So those files are easy to understand or are easy to use for data scientists. And so the second question about small national meteorological and hydrological services, I think AI can make these small national meteorological and hydrological services can make them more accessible, actionable, and equitable. So I said actionable. So there are numerical weather predictions centers like the ECNWF that are making AI-based models, data sets from private companies as open source and free of charge. So these models are from Microsoft or Google, but ECNWF are making these data sets open and for free. So I think that these resources provide valuable support for especially smaller national meteorological and hydrological services, allowing them to enhance their forecast by integrating AI-driven information into their prediction processes. And also, I said accessible. So there are cloud-based platforms that enables national meteorological and hydrological services the access of advanced forecasting tools without the need of investing in local supercomputing infrastructures. And also many technology providers, they are organizing training workshops and resources. And all this allows users to explore and apply these AI models through cloud-based services at no cost. And finally, equitable as well. So AI-powered chatbots and voice assistants help national meteorological and hydrological services disseminate forecasts broadly in local languages and formats that are more accessible to a diverse population. To the third questions about the roles and single authoritative voice of these national meteorological services. So I think the role of national meteorological and hydrological services, they provide information and services about weather. So I think they play a key role in supporting public safety, economic development, and environmental protection. So the HMEI and AccuWeather, we recognize that government national meteorological and hydrological services will always serve as the single authoritative voice for weather warnings. And AccuWeather has proudly worked with government national meteorological and hydrological services to ensure that all weather warnings that we display in our platforms are clearly marked as being from their official agencies, maintaining and strengthening the government's official voice for weather warnings. And I also think that it's important for governments to support these national meteorological services because they are public institutions, and the main goal is to help protect people during weather-related emergencies. So, for example, last year in Houston, Texas, where I live, so we had a very severe thunderstorm with tornado-like winds. And so the population wasn't prepared in Houston. We didn't receive a warning on time from the National Meteorological Service. And after the storm, people showed that the red frustration to the state and utility companies. And I think situations like this really highlight how important or how critical are the national meteorological and hydrological services. And so, as Arlene said, I think the partnership between private and public entities are very important. So they play important but distinct and complementary roles. So the National Meteorological and Hydrological Service will remain the nation's trusted public service for safety critical decisions. And on the other hand, private entities like AccuWeather will be more consumer and business focused, providing customized insights for decision making and daily life. And the collaboration is very important to enhance public safety and maximize the reach and impact of weather information. So at AccuWeather, for example, we operate one of the most widely recognized web and platforms, mobile platforms, reaching millions of users around the world. And because we reach so many people, we made a priority to integrate warning, watches, and advisories from 70 institutions around the world, including the National Weather Service, right into the AccuWeather app. So, for example, if the National Weather Service, they issue the thunderstorm warning for a specific area, our AccuWeather system will receive that alert and share this information through the app. And this way, we are going to help people stay informed and take actions when it matters most. Of course, when we share this information from the National Weather Service, we are making sure that we are marking this information is coming from the National Meteorological and Hydrological Service, from the National Weather Service. So yeah, to conclude, I think AI-based systems have the potential to significantly enhance capabilities of national meteorological and hydrological services by increasing the speed, accuracy, and the relevance of warnings, ultimately leading to more effective protection of life and property.
Excellent. Thank you very much, Lydia. So we have about 10 minutes to take some questions and maybe do a quick summary of what you've heard today. So the floor is open. We can take maybe one or two very quick questions, and we have people online as well. So our operations people will be monitoring the chat function. So if you have a question, you might raise your hand through that system. So, right, we have one question down here. You might state your name for those who are participating virtually, please.
Thank you so much, Mr. Chair. Allow me to thank all the participants for their insights about AI. I'm Albert Martis. I am an EC member, also a small island development states. My first question is actually it was a very nice way that the president of the INFCOM has shown the value chain of the organization, because that is actually the basics of where we would like to go. And the first question I have actually for all the panelists is, what is the problem we would like to solve with AI? Because that is actually very important. Why is it? Because at home we also start discussing about how to introduce AI in our system work. And the thing is actually there are three phases of AI. The first thing is actually you would like the AI to learn. The second one is actually you want the AI to reason or give you advice. And the third one, you would like the AI to act on its own. So those are the three phases of the AI. And the first thing is actually what we would like to, which problem we would like to solve with the AI. Because one of the interesting questions right now is, in our weather prediction, right now, we are on our way, we are very good, but still it's not generally, but community level. There is where we need some action.
Okay, Albert, thank you very much. We're going to lose our interpretation in 6 minutes. Okay. So I think we understand the question. So I'll hand over to the panelists. Who would like to go first? Professor Wu.
Yeah, that's really critical questions. I think the central point is what's the added value of AI to the current MS, right? That's you really want to ask. So according to our experience, I do feel that AI can really provide added value for the meteorological service. Why? Because, it really has very long term from the MS, which is highly dependent on the numerical modeling, which is very, very much computing resource intensive way of providing public service. So that means on one hand, we provide free services to the public. But on the other hand, we are highly relying on very huge amount of public investments. So that's why for AI at this moment, we can really develop more efficient, more rapid resource, the forecast results for the current MS. But it's a kind of, I should say, ensemble focused. No matter the foundation model from the Microsoft or the transformer-based model developed by Google DeepMind, they are all actually a kind of not really the accurate prediction. It's more like a kind of statistical prediction relying on the confidence interval. But they really help us to provide a kind of tool which can facilitate us to achieve more efficient meteorological service. So that's why I think the AI is to learn how to represent the real physical world of such kind of complex Earth physical world. And at this moment, I don't think they can really reasoning the complex mechanism of such kind of Earth system. But for the future, I hope we can reach that state. That means that for the AI, they can really understand the complex mechanism of the Earth system. But frankly speaking, there's still a long way to go. Yeah, long way to go.
A long way to go. I'm conscious that we've only 4 minutes left. And I would like to perhaps conduct some sort of a wrap up. So I might actually hand over to Co, who's the Deputy Secretary General of the World Meteorological Organization, Co Barrett, to perhaps reflect on behalf of all of us on what we've heard this morning from the magnificent presentations that are being given by the whole panel. So over to you, Co.
Thank you, Owen, and sorry to not be at the podium. I just thought I'd save a minute to walk across the stage. Well, hard to sum up all that we've heard this morning, but I guess I'll just say, given the rapid development of AI and the ways it's already transforming operational forecasts, I'm certain that you will agree with me that this session was an important one to include in our EC agenda. And the session did not disappoint. The sharing of perspectives, both from the public and private sector, the sharing of tools, and the potential to democratize access to hydrological and meteorological forecast models is all very promising, as is the ability to apply AI to enable better adaptation to risks, even at the local level, and in service to sustainable development. So I think there's a tremendous amount here that offers promise. I think we could have filled twice the time, really, with information from our panelists, but importantly with questions from all of you. But I maybe just want to quickly say that I think we should all consider this to be the start of a conversation. And to be something that we fully embrace, because I think the point that enabling the kind of leapfrogging of capabilities, especially in the global south, is something that we in WMO should take very, very seriously as an opportunity for all of us, both to learn, but to also kind of enhance quickly the ability to provide operations in a more effective and efficient way. So that's probably not a full assessment, Owen, but just quickly my observations.
Thank you very much, Co. And the time available, I think that summarizes the magnificent presentations that we've actually heard this morning. So in the minute that I have available with the interpreters, thanks again to the interpreters for extending their time with us. I have the function of closing the sixth high-level session of the OCP, and I'd like to thank all the speakers again. I think they deserve a round of applause. And I'd like to thank everybody here for attending and for those who've joined us online as well. Your attendance has been greatly appreciated. Apologies, there hasn't been more time for questions, but if you want to engage further with the information provided, all videos and photos and the presentations are available on the public-private engagement website, or will be soon on the WMO website. So thank you very much. The session is now closed.
Thank you. Just a couple of announcements for everybody before they go. The interpreters feel free to leave. Group photo time, please. For the traditional group photo, please proceed out front of the building. We try to get you all while you're looking so fresh and vibrant on day one. So we'll have the picture out front. Just a reminder, the sessional committee on the review of membership of bodies reporting to the EC will meet at 1:30. It's in hybrid form. For those of you here, Salle B next door, Salle B, and there'll be a separate link sent for people online. Lastly, a mobile phone was left at the coffee bar. It's with security if you're missing your phone at the front door. So please, everybody, if you could proceed outside for the photo so we can all have some lunch.